Hello, this is question 6. So you have an algebraic fraction and you have to write in partial fractions. So let's go to do that first. So that fraction will be written as I have two factors as an a divided by the first factor, 1 minus x, plus a b divided by the second factor. And which means the numerator, so 5x plus 10, is going to be equal to the other numerator, which is going to be a times by this plus b times by this. Yeah, and then the denominators are going to be equal already. So a times 2 plus 3x plus b times 1 minus x. How you do this is up to you. You can equate coefficients, compare coefficients, or substitution, or a mix of both. I'm going to do a mix of both. So just because this one is very easy to substitute, this one would be minus 2/3 is less easy to substitute. So I'm going to substitute that by x equal to 1, which means this whole thing is going to be 0. So the left hand side I have 5 times 1 plus 10, 15 is going to be equal to 2 plus 3 times 1 is 5 times a, which means a is 3. And then I'm going to compare coefficients. So for example, I'm going to compare the independent term. Yeah, so 10 is going to be 2a plus b. Yeah, so if I compare 10 is going to be 2a plus b, but 2a I know is 6 because a is 6, so I have 10 is 6 plus b, which means that b is 4. So I have a3, b4, which means my expression is going to be 3 divided by 1 minus x plus 4 divided by 2 plus 3x. So this is my algebraic fraction written as partial fractions. Then b, hence, so I'm going to use this in finding ascending powers of x and up to including x squared, the binomial series expansion of this function. So for the second part, we are going to write that our function is going to be this thing here, but we are going to write this in the numerator. So it's going to be 3 1 minus x to the power of minus 1 plus 4 2 plus 3x to the power of minus 1. What we are going to do is to use binomial expansion for this, and then put everything together. So the first one is 1 minus x to the power of minus 1 is going to be 1 plus nx, n is minus 1, x is minus x, plus n, which is minus 1, n minus 1, which is minus 2, divided by 2 factorial, and then minus x squared. And I can stop now because they tell me up to x squared. And then I organize I find the coefficients. So I have 1, minus 1 minus x is plus x, and then minus 1 minus 2, you can do with the calculator, you know, but this is 2 divided by 2 factorial is 1, and then minus x squared is plus x squared. So this is my first expansion. Then I'm going to expand this one, so 2 plus 3x to the power of minus 1, 2 plus 3x to the power of minus 1. Remember, this has to be 1, so the first thing you have to do when that happens is to get factorized by 2. So I have 2 to the power of minus 1, and then I have 3 this. Yeah, just dividing everything by 2 and getting the 2 outside. So this is going to be 2 to the power of minus a half, or if you want, you can write 1 over 2, which is the same. And I'm going to expand this bit here. So it's 1 plus nx, n is minus 1, x is 3/2 x, plus n minus 1 times n minus 1 minus 2 divided by 2 factorial, 3/2 x squared. And I can stop here because I need to do only up to x squared. Then I have 1/2 brackets 1 minus 3/2 x, I'm just finding the coefficients again. So 3/2 x and 9/4 x squared. And now finally I multiply by the 1/2. So I have 1/2 minus 3/4 x plus 9/8 x squared. And now I go to fx. So I go back to fx. Fx is this thing here. So it's going to be 3 times this expansion. So fx is going to be 3 times that expansion, which is 1 plus x squared, plus 4 multiplied by this expansion. So 1/2 minus 3/4 x plus 9/8 x squared, and so on. Yeah, and I expand brackets and reorganize. So I have 3 plus 3x plus 3x squared plus 4 times 1/2 is 2 minus 3x plus 9/2 x squared. And then I put the coefficients together. So 3 plus 2 is 5, 3x minus 3x are gone, and 3 plus 9/2 is 15/2. So 15/2 x squared. So that's it, up to x squared. And the last thing they say, find the range of values of x for which this expansion is valid. So I have 2 expansions in one. I have this one and this one. Yeah, I have expanded 2 binomials. This one is going to be valid when x or minus x. So when the absolute value of minus x is smaller than 1, which means that absolute value of x is smaller than 1. And the other one is this one. This is going to be valid when this bit here is smaller than 1. So 3/2 of x. 3/2 of x is smaller than 1, which means absolute value of x is smaller than 2/3. And both things have to happen at the same time if I want both binomials to be able to work. So it has to be smaller than 1 and smaller than 2/3, which means it has to be smaller than 2/3. Yeah, both things happening at the same time. That's all. That's everything you have to do in this question.